Welcome back to our Knowledge Bank series, where we uncover the invisible threats in the air around us, pollutants that quietly affect our health and environment. What if I told you that the very same gas that shields us from the sun's deadly ultraviolet rays could, at the same time, be damaging your lungs and making it harder to breathe? Sounds contradictory, doesn't it? Yet, this is the reality of ozone, one of the most fascinating and at the same time most misunderstood gases in our atmosphere. Let's understand what ozone, O3, is. Ozone plays a dual role. High in the stratosphere, it acts like Earth's sunscreen, shielding us from dangerous ultraviolet rays. But near the ground, in the troposphere, it becomes a toxic pollutant, harming our lungs, crops, and ecosystems. A simple way to remember: ozone is good up high, but bad nearby. Ozone, O3, is a molecule made of 3 oxygen atoms. It's part of the tiny fraction, less than 1%, of gases that make up our atmosphere. Despite being rare, its impact is huge. Recognized by the US EPA as one of the 6 key air pollutants, ozone is a pale blue gas with a sharp, pungent smell, detectable even at very low levels. But unlike smoke from a chimney or exhaust from a car, ozone isn't directly emitted. Instead, it's formed when nitrogen oxides, NOx, and volatile organic compounds, VOCs, react with sunlight. That's why ozone spikes on hot, sunny days. So, where exactly does it come from? You might think ozone pollution is just a city problem, but the truth is, it can impact even remote rural areas. Why? Because ozone is a secondary pollutant. It forms in the air rather than being released directly. Tailpipes and factories, cars, trucks, power plants, and industries release NOx and VOCs that combine in sunlight to form ozone. Long distance travel. These gases can travel hundreds of miles, so even areas far from cities can experience ozone smog. Sunlight's role: since ozone formation depends on sunlight, levels usually peak in the afternoon. Photocopiers and printers. That sharp smell near a copier, that's ozone. Air purifiers. Some devices intentionally produce ozone, but instead of cleaning the air, they pollute it. UV lamps and appliances. Ultraviolet light in lamps, refrigerators, and even steamers can generate ozone indoors. Medical sterilizers. Hospitals sometimes use ozone for disinfecting equipment, but overexposure is hazardous. Clearly, ozone isn't limited to urban smog. It's a pollutant that can appear indoors, outdoors, and virtually anywhere sunlight meets pollution. Now, why should we worry about it? Let's explore its impact on our health and environment. Over 131 million people in the US live in areas with unhealthy ozone levels, and the risks are serious. Respiratory irritation. Ozone inflames the lungs, throat, and eyes, leading to coughing and discomfort. Aggravated diseases. Asthma, bronchitis, and heart disease worsen with ozone exposure. Long-term damage. Even if short-term symptoms fade, prolonged exposure reduces lung function. Vulnerable groups at risk: children, outdoor workers, and those with pre-existing conditions are most affected. Early death. For people with lung or heart problems, high ozone exposure increases the risk of early mortality. Plant and crop damage. Ozone reduces photosynthesis, leading to weaker plants and lower crop yields. Economic losses. Global studies have linked ozone to yield losses of 2% or 14% in maize, wheat, and soybeans, resulting in millions of dollars in annual costs. Smog formation. Ground level ozone is the main ingredient of smog, reducing visibility and air quality. ecosystem threats. Increased UV radiation harms plankton, disrupting marine food chains. Ozone pollution doesn't just choke our lungs, it damages economies, food security, and ecosystems. So, what can we do about it? Let's see what corrective measures we can take. The first step is monitoring ozone levels to identify areas where air quality fails to meet standards. Once we identify the hotspots, we can take action. Stricter air quality laws: walk, cycle, carpool, or use public transport. Electric vehicles cut VOC and NOx emissions. Refuel cars after dusk and avoid overfilling the tank. Regular servicing reduces exhaust pollutants. Turn off engines when parked to prevent unnecessary emissions. Select paints, cleaning agents, and materials with lower volatile organic compound (VOC) levels. Avoid ozone-generating air purifiers. On high ozone days, avoid strenuous outdoor exercise and stay indoors until the air quality improves. Cleaner air starts with us, our choices, and our voices supporting stronger policies. But to act effectively, we first need to measure ozone accurately. Let's explore how it's done. Several technologies help scientists and regulators measure ozone in the air. UV photometry, the standard method. An air sample is split into two parts. One is scrubbed to remove ozone, the other is exposed to ultraviolet UV light at 254 nanometers. Since ozone absorbs UV, the difference between the two samples reveals ozone concentration. This is the most widely used and accurate method for regulatory monitoring. Gas phase chemiluminescence. The light reaction, ozone reacts with ethylene, producing a faint light. A photomultiplier detects this glow, which is proportional to ozone levels. Although less common today, it remains effective in certain applications. Semiconductor sensors, compact and cost-effective. Ozone molecules react with a thin layer of metal oxide on the sensor's surface, changing its electrical resistance. The resistance shift indicates ozone levels. These sensors are affordable and small, but they use more energy than other types. Electrochemical sensors, precision at low levels. Ozone diffuses into a small electrochemical cell, generating an electric current. The current strength matches the ozone concentration, providing highly accurate readings even at low levels. Perfect for real-time ambient monitoring. Each of these tools helps us track ozone pollution, paving the way for cleaner air and healthier communities. Ozone comes from our industries, vehicles, and even household appliances, and it impacts our health, food, and environment. But by monitoring ozone, enforcing cleaner policies, and making smarter everyday choices, we can tackle this invisible threat. We hope this gave you a deeper understanding of ozone and its importance. If you have questions or would like to explore further, we're always here to help. Stay informed, stay safe, and keep breathing clean.